AI, machine learning, and deep learning in smart healthcare. So we are today on final day of the FDP. We started the journey together on 27th of September, and we reached smoothly towards the end on 5th day. So we have two technical sessions in the first half, followed by in the second half. First, there will be a test, and then valedictory session, and then attendance and feedback, which are mandatory to for successful completion of this FDP as per AICTE mandate. So now we already have our respected speaker of today's first session, Professor Paramartho Dotto from Vishwabharati University. On behalf of the organizing committee, sir, I express my heartfelt thanks to you for accepting our invitation and for being with us. Sir, I welcome you to the FDP.
Thank you. It's my honor to get the invitation. Am I audible, by the way?
Yes, sir. Yes,
Yes,
sir.
sir.
Okay.
Yes, sir. It's clear.
So my relation with Macaut is quite,
Yes, sir.
long.
Yes, sir.
So it's a,
In various academic events.
yeah, it's a nice
Yeah.
bonding. So uh, in fact, whenever some invitation or anything, any assignment comes from Macaut, I become very much, very much inclined and very much motivated to accept it.
Yes, sir. We
Somehow
have a
I feel
long
at home.
association with you,
So thank you.
and
Thank you.
we are thankful we get you in various events, in spite of your busy schedule and other various assignments.
No, I feel at
So,
home. You see,
thank you,
the
sir.
truth is this.
Thank you so
Uh,
much, sir.
okay.
So before sir starts or the session is over to sir, a very brief introduction about sir. Uh, Professor Paramartho Dotto is currently a professor in the Department of Computer and System Sciences in Vishwabharati University, Bolpur, Shantiniketan, West Bengal, India since November 2007. He did his bachelor's and master's in statistics from Indian Statistical Institute, Kolkata, India in 1988 and 1990 respectively. Subsequently, he did his Master of Technology in Computer Science in 1993 from Indian Statistical Institute, Kolkata, India. Professor Datta did his PhD Engineering in 2005 from Bengal Engineering and Science University, Shibpur, India. He is the co-author of 8 authored books, apart from 13 edited books and more than 240 research publications in peer-reviewed journals and conference proceedings. In addition, he is the co-inventor of 17 published patents, which is really inspiring, sir. He is a fellow of Institution of Electronics and Telecommunication Engineering, Optical Society of India, Institution of Engineers India, senior member of Association for Computing Machinery, and many more. He is also the recipient of Excellence in Science and Technology Award 2018 conferred by the Indian Science Congress Association, Government of India, and INSA Teacher Award 2019 conferred by the Indian National Science Academy, Government of India. The introduction that I have just presented is a very brief introduction. There are various activities with which, excellent activities and achievements with which Sir is associated. So without wasting any further time, I will over the session to Sir, and his title of today's talk is Machine Learning in Detecting Human Emotions from Face Image Sequence. Over to Sir.
Thank you, Dr. Vishwas, for your nice introduction. So, in fact, as you have indicated, without wasting time, let me get into the topic of today's talk. So let me share.
Yes, sir.
Is it visible now? Is
No,
it
sir.
visible?
Please reshare it, sir.
Okay, I have to. Is it visible now?
Yes, sir.
Yes,
So
yes,
if you
visible.
can make it in full view mode.
Yeah, yeah, I'm doing. Now it is fine, right?
Yes, sir.
Uh, I am also audible properly. Okay.
Yes, sir.
Okay. My dear colleagues, uh, let me address as colleagues because I personally believe that being in the same institute doesn't make uh, colleagues only. So, in extended sense, colleagues are those who are in the same profession, who are in the same service, who are trying to serve the society in a so-called similar manner, whether in terms of academics or research. So, in that sense, we are colleagues with one another. It's not only the organizing or organizers part, but also the audience. So, in my opinion, the most effective way to address, start addressing, is by indicating my dear colleagues. So, my dear colleagues, uh, it's a nice opportunity that I am going to ventilate some of my or share some of my recent works. In fact, when there is a history behind, I take 1 or 2 minutes to share that. Well, a few months back, when Dr. Bishwas approached me to deliver an invited talk on a topic which deals with smart healthcare, I was really, what should I say, scared or annoyed because, exactly speaking, healthcare or medical domain is not exactly my purview. So I had a discussion with her. Possibly she will attest that, some of my works are going on in the field of face recognition, in the fields of, you know, emotion, dealing with emotions as reflected in face images of human beings. Uh, and that means that face image or face image sequence reflects some emotional component or emotional aspect of a human being. And moreover, when it comes to the question of some say, for example, a human being is suffering from some pain, then there must be some reflection in the face, and accordingly, there will be some clue will be evident from the face image of that particular person at that particular point of time. What I mean to say out of this is that um, by virtue of being the being a very effective reflection of or capability of reflecting human emotions, when it comes to the question of, say, medical intervention or medical attention in respect of psychological aspects or psychological issues associated to a human being, there may be some, some bridge between these two. And that is basically the background of, what should I say, taking the venture to share some of my current research findings, even though the domain is smart healthcare. So I may please be forgiven if somehow some of you feel that it is not exactly within the purview or scope of the present domain. But nevertheless, there are some interesting observations or some interesting findings, excuse me, that we that we hope that we may share with one another, and as a result, some uh, good feeling the audience may have. So, with this hope, let me start. So now, the title of the talk is Machine Learning in Detecting Human Emotion from Face Image Sequence. Uh, so it has got its background. If one of my student, one of my PhD scholar, he has carried out his research uh, in this domain on this particular problem. So essentially, what I am going to share today is basically the findings, joint findings of him and myself. And I mean, the findings that we had, some of them are quite interesting. So the area or the problem that he is working on, he's about to submit his thesis. So the work or the problem domain is that consider the face image of a particular human being at a particular point of time. Say it is neutral. Typically, in normal situation, the face image reflects neutrality of a human being. Now, some event occurs and the person becomes, say, annoyed or becomes surprised, becomes angry. So what happens is that if we look at the face image, there will be definite change in the face of the face expression of the concerned human being. So there will be a transition from neutrality to, say, anger, or neutrality to surprise, or something like that. So it's a transition over time that takes place from, say, neutrality to anger, or neutrality to surprise, or neutrality to sadness, whatever it may be, depending upon the phenomenon that took place. So human emotion is very sensitive to physical phenomenon that takes place around. And the work that was carried out by my scholar Muhammad Nasir is precisely on that, where the data we worked on is basically the transition from neutralities, I mean different type of transitions from neutrality to, say, surprise, or neutrality to say sadness, or whatever, different type of transitions may be there. And basically it is a classification. Now comes to the question of the computer science task. Basically the classification of the nature of transition that takes place, reflecting the change in emotion that is taking place in a human being. So that is what the objective is. Now I mean, at the very beginning, I want to make it clear that from a computer scientist's point of view, it's the effort that we have put in. But honestly speaking, this is an area where it's a question of, I mean, by nature it is interdisciplinary, because it has got its cognitive component also, where the application of cognitive science is there, because it deals with human emotions. Honestly speaking, emotion or change in emotion is not exactly the task of a computer scientist. Why, how different emotions change, what exactly are the genesis, all these things are beyond the scope of computer science. So far as our problem is concerned, it is basically the transition as reflected in face images and its classification. And one of the biggest problem even today is that the mapping from emotion, we know that there is a specific reflection of emotion of a human being into his or her face image or face. So basically emotion is cause, and whatever is visible in the face image is the effect or result. So it's basically some sort of mapping or relationship must be there, dependency relationship. But even today, the nature of this particular relationship, what exactly is the nature of relation in formal sense or in mathematically closed form, is not yet available. It's an open problem. In fact, that is the reason. That is why I told you that it is sort of an interdisciplinary type of domain where experts from different fields have to take the initiative jointly. So with this background, now the stage is set for proceeding further. So the talk objective is identification of spatio-temporal. I am going to explain the particular terminologies, why they have been used. First, let me read out. So identification of spatio-temporal information in transition of human emotion using facial geometry-based approach. Now, why spatio-temporal? Because we are dealing with spatial image. So that is spatio. Why temporal? Because we are dealing with, or we are trying to interpret sort of image sequence or video sequence of face images, where time-dependent face images are available, indicating the nature of transition as reflected in the face image because of change in emotional status of a human being. So that is why it is temporal. So putting together, it is spatio-temporal. Next comes spatial geometry-based approach. I owe an explanation why geometry-based. We shall see in due course of time that there are different type of approaches to deal with this particular type of problem. Some works have definitely been done. Because of shortage of time, it may not be possible to go into the details of sort of survey on different works that has been done. But I mean, in short, it can be said that there are different type of approaches, one of which is basically geometry-based approach. And our present work is basically dealing with geometry-based features and all that. So that is the background. Now, facial expression analysis. Then innovative methods, innovative in the sense that not exactly reported earlier. So that is exactly what our finding is in the present context. Then the change detection in human emotion. Okay, so this is basically the sort of roadmap we can, as we may call it. Now, human emotion recognition system, please note that it is emotion recognition system. So I have indicated that emotion is the cause, and whatever is reflected in the face images, that is the effect in the present context that we deal with. So basically, it's a computer vision or image processing problem that we have to deal, and using some classification. The scope is the task is a classification task, and for this, effective classifiers are used, and their performance are studied. Am I audible, by the way? Is it
Yes,
okay?
sir. It is audible, sir.
Okay. Okay, now, intelligent emotion recognition is the process of understanding human behavior, identifying mental disorders and human-computer interaction. This is what we have indicated at the very outset, that some mental disorder or some mental, inappropriateness or discrepancy or some deviation or deflection from normal human, mental setup. That is what exactly we are trying to deal with for the present. At the left-hand side, there are different type of expressions: anger, disgust, fear, happiness, sadness, and surprise. So basically, we are dealing with this. These are called basically basic expressions, basic facial expressions. There are 6 such, as I have pointed out here in different images. Now, if I am asked, well, is it possible to confine the expressions only within these 6 categories? The answer is no. For example, the one I started with, when it comes to the question of pain, that means a human face which is apparent is a reflection of pain. We understand. Now, if the simple question is asked whether a face expression indicating suffering from pain comes under the purview of any out of these six? Answer is unfortunately no. Now the question is, I mean, what happens? There is the biggest challenge that I indicated earlier. Identification of emotion or different emotional, emotional background, emotional status of a human being, and its characterization in formal sense is an open problem yet. It comes under the jurisdiction of cognitive science, which honestly speaking is beyond our present scope. But what is understood from study is that these six categories, anger, disgust, fear, happiness, sadness, and surprise, these are basic categories or basic facial expressions as they are called. And whatever other type of facial expressions become available, they are not basic characteristic, they are somewhat mixture of different basic characteristics in some suitable proportion. Which means that if once again we go back to the original problem, say for example pain. So pain, as as is available, as the literature is available at present, is interpreted as a combination of some suitable combination of these six basic facial expressions. Okay. Now, if I am once again asked, well, what are the components? What are the basic components that give rise to pain or expression of pain? Sorry, I cannot answer. It's very difficult for me to answer. And in fact, to be honest, unless the formal characterization is available, it's very difficult to identify exactly what type of combination, basic facial expression combination, gives rise to what. So that is why I'm saying that it's a big domain where there's scope of research, interdisciplinary research, which, to be honest, even today is in a very nascent stage. An ability to intimate the human sign language in non-verbal communication shows the importance of facial expression recognition or machine-based facial expression recognition system. Now, when I am talking with somebody and for some reason or other, he or she gets angry, I can understand while communicating. Because as a human being, I am quote unquote an intelligent entity or person. But when it comes to the question of machine being able to understand or interpret the sadness or happiness, or as the case may be, from a face image, that is a challenging task, in fact, a task of classification. For the present, we have confined our transition from neutrality to any of these six basic categories only. So that means neutrality to anger, neutrality to disgust, or so on and so forth. Transition from neutrality to any other mixed expression, or say from surprise to anger, that means the starting point is say not neutral, something else. So, or say sadness to surprise to sadness, say for example. This type of transitions are not taken care of here. They are beyond the scope of the present discussion. So let me make this point clear at the outset. So our jurisdiction of investigation is very focused, which we are trying to deal with, and I help share the results obtained, algorithms used, results obtained, so on and so forth. Facial expressions of human alone have 55% contribution to capture the internal meaning. Spoken messages This is message, MESS, spelling mistake, sorry. And in case of vocal and verbal cues, it has 38% and 7% respectively. This is as per existing report available in the literature. Okay, so let us proceed with, by accepting it. Now, 6 basic facial expressions of human are universal. So these are anger, as has already been indicated: anger, disgust, fear, happiness, sadness, and surprise. I hope I am audible, right?
Yes, sir.
Am I audible? Yeah.
Yes, sir.
Okay.
Yes, sir.
So occasionally or periodically, I will, because I am
Sure, sir. Sure,
having
sir.
only one device. So please respond. Okay. So now, when it comes to the question of background from system perspective, a traditional facial expression recognition system, what is known as FERS in short or in brief, uh, it has got two components or two parts. One is feature extraction part, another expression classification part. Where feature extraction part has got two ways, basically, or two avenues. One is appearance based, another is geometry based. Please recall that I indicated a few moments back that there are different methodologies, and our present one is geometry based. Even though some appearance based model specification is being taken for the purpose, so that way you may interpret it. It's somewhat a hybrid in the truest sense of the term. But when it comes to the question of the recognition task or classification task, it is entirely geometry based. We shall see that there is a model called active appearance model, which is somewhat appearance based platform. Some result or some findings of active appearance model is taken for application of requisite geometry in our classification system. So we shall see, we shall come to that very soon. The other part, when it comes to the question of expression classification, that means the classifier being under consideration, there may be multi-layer perceptron, support vector machine, hidden Markov model, etc., etc. So there are different classifiers may be used. In fact, when it comes to the question of the entire thesis of my scholar Nasir, he has dealt with different type of classifiers. They are, relative performance, pros and cons, everything has been studied. But for the present scope, because of paucity of time, we shall not elaborate further. We confined with multi-layer perceptron classifier and its results coming out of that only. And multi-layer perceptron, possibly most of us know, if not all, it is the classifier technique which is maybe somewhat primitive in the sense, it came in the literature or reported in the literature quite time back. But even today, it's by virtue of its robustness, it is even today a very popular classifier. And even today it is used. Okay, so it's not the original variant of multi-layer perceptron, but the customized multi-layer perceptron or variant like that, as may be suitable for a problem, for specific problem, tuning that, and accordingly, even today MLP is found to work very nice. So that is one of the reasons why it is so popular even today. So our present reporting is confined within the use and results obtained from multi-layer perceptron. Now, just a distinction: appearance-based feature extraction It uses different statistics of image pixels and produces the feature set by extracting histogram-oriented feature information from face images. So that is the basic spirit. And on the contrary, when it comes to the geometry-based, this should be geometry-based. Geometry-based feature extraction. It uses geometric locations of facial points on face images. So basically, a face image is considered as an image, and I mean the entire process on that will be based on geometry. So, and accordingly, it produces the feature set by extracting geometric shape or other geometric information, associated information from the face images and subsequent processing on that. So there lies the difference between these two feature extraction approaches, appearance-based and geometry-based. Now, some of the challenges. With static image-based approach, it uses only a single image, either neutral expression or peak expression. Peak expression means maybe fear, that means disgust. Out of the 6 basic categories, face image is a peak image. Okay? So when it comes to the question of exploring static image-based approach or static image-based approach is coming out of the exploration. Excuse me. So it's basically a single static image, whatever the nature of expression it may contain, that is considered and its classification is done. Now, the limitation is that it's difficult to trace behavioral changes in emotion transition due to the persistent gap of facial geometric information. Now comes the question. So now the face image that one is observing, say for example, is neutral, and that fellow is gradually becoming angry for some reason or other. So there will be the change in face image. There will be a change in the geometry associated or underlying within the face. And this particular transition from neutral to say anger or neutral to say disgust, that means some peak. So this transition, identification or classification of this transition is what the challenge is for the present. And in order to do that or achieve that, the method that we adopt is basically geometric information. So that is why it is a geometry-based approach. But we shall see that the selection of points will be on the basis of existing active appearance-based model, which is a very popular and very effective method at present, used frequently by the research community associated to this particular type of domain. So we shall take assistance of active appearance model output and apply them to shape our geometric information that we adopt. Okay, so that is what exactly we are trying to do for the present. So look at it. So the left-hand side image is a neutral expression, and the right-hand side image is a happiness expression of the same object, that means the same human being. Now, look at the face, respective faces, face images. We understand that, well, the same person or the face of the same person, so the starting point is the left-hand side figure, and the terminal point is the right-hand side figure. That means the peak expression. Peak means here happiness. So the transition from the left-hand side to start with to the right-hand side one at the other extreme, there may be intermediate gradual change over time. giving rise to a sort of video sequence of the transition of images, facial images I am talking about, definitely. So how to from this how to categorize or how to classify this nature of transition, that is what the challenge is for the present. For the present, it is the video based or dynamic approach, not the static, where this is the transition. So from frame 1 is basically the neutral, and frame 10, that means the last one, is the happiness, the peak one. And there is gradual transition from neutrality to the peak one, that means happiness. So this transition is to be characterized or categorized or classified. The task is this: starting from neutrality, there is a transition, neutrality to, say, maybe anger, on to happiness, to surprise. What type of change is taking place given the image sequence? I mean, temporal image sequence, a video sequence of images like this. Needless to say that each and every image in the frame, whatever frame you think of, any intermediate frames, for example, or the extreme frames, they reflect, I mean, each and every one reflects some emotion that is taking place behind. So emotion is the cause I have indicated, and these different frames, as we visualize here, they are basically the results or effect. Now, our task is to, from this transitions are given, from these transitions, which type of transition it is, try to identify that or detect that. That is what the problem is. And the original problem should be where exactly the computer science or exploration of computer scientists fall short of is, if possible, to characterize the nature of change of emotion. Now, I have indicated one time and again that the mapping from emotion to expression is yet an open problem, and it is not alone computer scientists can help to solve this problem, identify the mapping. It requires collaborative or interdisciplinary participation. Distortion of facial aspects is found when emotion evolves with several intervals of time. Okay. Now, temporal changes in emotion can be recognized through frame by frame facial pattern analysis. So when it comes to the question of our task, we look at the problem that is a change in pattern, and it's basically a task of pattern analysis, pattern recognition and analysis. Is it all right? Am I audible, please?
Yes, sir. Yes, sir.
Am I audible, please?
Yes, sir. Yes, sir. Yes, sir. It is audible, sir. Hello?
Am I audible?
Yes, sir. Can you hear, sir?
Yeah,
Yes, sir.
I am also.
Yes.
Thank you. So, efficient ways of tracking records regarding the deformation. Basically, deformation is taking place, and these deformations are to be dealt with geometrically. That is what we have focused on. Regarding the deformation of face geometry over the time interval, impact of various geometric representations on the transitional emotional recognition. This is reflected in terms of, or the metric is recognition rate in percentage. Coming to the contribution, what we are trying to discuss for the present session is a frame-based facial expression analysis to estimate flow control of behavioral changes in the transition of human emotion available in terms of video clips. So input is basically video clips, indicating, emotional changes of a particular human being as reflected in respective frames of the video. Tracking landmark positions now comes. For the first time we are introducing the term landmark, and here comes the question of active appearance model. Tracking landmark points or positions from face frame sequence with the applications of AAM. AAM stands for active appearance model, the one I was talking about, which is a very effective method and widely accepted model considered by the relevant community to trace the frame-wise deviation of feature points. Now, why or what is the contribution of active appearance model? In short, active appearance model is capable of identifying the salient points known as landmark positions on the face images. Now see, one has to understand that in the face image there are ample number of pixel positions of points. Now all the points are not that much important when it comes to the question of recognition task. Some of the points are very much sensitive to any change in emotion or any change in deflection, and some points are not. So the question, the basic contribution of active appearance model is this: it identifies those points which are showing the maximum sensitivity to any change in emotion. Okay, so which means that those points, since those could be identified, now those points can be, those landmark points can be taken into consideration for further processing or subsequent development, because these are the points which are responsible or which are found to be sensitive to change in emotion to a very, very adequate degree, I should say. So for the purpose of recognition, these landmark points are very important and they may be considered as the starting point. In fact, to be honest, for the present study that I am sharing today, here landmark points are considered as the starting point. Now, one point to note is that active appearance model, we shall see in very soon that as a model, it is capable of capturing 68 landmark points in a human face image, which are considered to be most sensitive, as I have indicated. Now, for our study, we have seen that all these 68 points may not be that much important for our purpose. In fact, we have downsized these 68 many landmark points into a set of 23 only, and ensuring very good result, quite impressive result, which means that using 23 most sensitive out of these 68 many available from active appearance model based approach is quite adequate or reasonably adequate for the present recognition task. We shall be coming very soon. Next comes introducing a fuzzy triangulation technique that is used to build fuzzy triangle shapes by taking a trio combination of landmark points to assess the fuzzy relationship among major portions of the face. Now in the face, eyes, eyebrows, nose and lips, these are the sensitive regions where change in emotion basically influences. Okay. Discussing the significant influence of the 5 different fuzzy triangle membership signatures. So now this is exactly what the contribution is. I have just in the previous slide I have explained that or pointed out that these landmark points we may pick up for our purpose. Now basically let me try to provide some motivation. Hopefully, I hope that will make things easier to understand. So take any 3 points, 3 landmark points. Geometrically, a triangle may be formed. Now the shape of the triangle may be of various types. Now, interestingly, for a neutral face image, a particular triangle or its nature will be different from the triangle formed by, say, anger with the same 3 points, if we consider, of the same person. So the person remaining same, 3 points chosen remaining same, 3 landmark points I am talking about. Accordingly, the triangles are formed. The one triangle in neutral expression and the one triangle in, say, anger expression, the nature of triangle in terms of shape or otherwise will be different. Now, here exactly the contribution is, if we are able to get the information as to the nature of triangle and trying to categorize accordingly may be effective. So that is the motivation. And this is not a single triangle only. Out of these 23 triangles, so there may be 23 C3 many triangles. That means 1771 many triangles. We shall be seeing very soon. And this 1771 many triangles in a particular sequence gives rise to what is known as a signature. And this signature, the sequence is very important here. This signature it plays a very strong role, very important role in so far as recognition task is concerned. For the present scope, different type of triangle or their classification may be considered. Isosceles triangle, right angle triangle we know from our school day geometry sense. Right isosceles triangle, equilateral triangle, and other type of triangles. So different type of triangles may be there. Now, these are understood. What is important or interesting is every type of triangle and the signature generated out of that has got its, its flexibility, and that is why these are basically fuzzy signatures. Let me explain once again. Say a triangle with 60 degrees, 60 degrees, 60 degree. We know it's an equilateral triangle. There is no question on that. Now, if the angle distribution of a triangle becomes 59 degree, 60 degree and 61 degrees here, is it an equilateral triangle? Answer is no. Classical mathematicians will say no, it is no, never, it can never be. But if a triangle is drawn with this angle specification and on a piece of paper and it is demonstrated from a far separated distance, well separated distance, and visually if it is asked, the same mathematician in all likelihood is going to say, oh well, it's a which category of triangle it is? It is an equilateral triangle. The reason is that minor deflection, even in this angular specification, is just to give you an example, may not be that much sensitive to human perception. vision perception. So some tolerance or some approximation may be thought of. Some tolerance or approximation may be thought of, and in nature or in this type of processing, dealing with uncertainties or imprecision, we have to be accommodative to accommodate such flexibilities or approximations or deflections to a reasonable extent, up to a reasonable extent. Otherwise, it is not possible to identify or detect or recognize imprecise things correctly. It's never possible. So this is the genesis why our fuzzy, the use of fuzzy, word fuzzy is there. So accordingly, now it is, earlier it was isosceles triangle signature, now it is fuzzy isosceles triangle. Okay. Similarly, fuzzy right triangles, fuzzy equilateral triangles, so on and so forth. So it means that now in this new scenario, a triangle with 59 degrees, 60 degrees, 61 degree angular distribution is classically may not be an equilateral triangle, but it is definitely, it belongs to fuzzy equilateral triangle with reasonable degree of membership, good degree of membership. And this type of flexibilities are exploited for the present scope. And by virtue of them being exploited properly, they show good results. They yield good results. We shall see. Briefly examining the system performance, now comes the question of application. Performance on 3 benchmark phase sequence datasets. CK plus is Con-Canada database. Okay. Then MMI, MAG, these are different benchmark datasets used for this particular domain. And the MLP or multi-layer perceptron is the classification task. So there is a corresponding publication, just it is given there. This is the flow diagram. So I have image sequence, because get into it very quickly. Identification of landmark points, smart sizing of landmark points, that means 68 to 23 many. Then fuzzy triangle formation, different categories. Accordingly, their membership contents are calculated or computed. Features are extracted. I mean, signature-based features are extracted. Fuzzy signature-based fuzzy signature-based features are extracted, put into multi-layer perceptron classifier for classification, and eventually MLP. It's a supervised mode of learning. So the multi-layer perceptron is trained, and after adequate training, it is in a position to recognize unknown input properly. So that is typically the flow. Okay, so landmark generation using active appearance model. So the original image frame is the left-hand side image. After applying active appearance model, or AM in short, 68 landmark points are selected. This is the middle figure. Possibly you can find it. And we didn't work on 68 landmark points given or provided by active appearance model. Rather, we identified 23 out of these 68, the most important. And these 23 landmark points are taken into account for subsequent processing. Active appearance model is a computer vision algorithm for mapping a statistical deformable model of shape and appearance object into a new image. This is what active appearance model contributes. This model plots 68 landmark points on the face frame shown in figure 5. Only 23 landmarks are found as vital as per the study available in some reference, which are mapped on major face portions: eyes, eyebrows, nose, lips, shown in the right hand side figure. So which means that these regions in the face, namely eyes, eyebrows, nose, lips, they are most sensitive to change in expression or change in emotion. And that is why they are taken into account or into consideration. I am audible, right? Am I audible?
Yes, sir.
Okay. So I may please be excused for drawing a triangle which we were used to handle in our school days. You might wonder, well, after a long time, why these geometric, why these geometric figures once again are going to torment us? No, the basic reason is that the task that is being presented here is basically based on this geometry, very simple geometry. Okay, and even simple Euclidean geometry may be very effective in different contexts, is vindicated with this application. So the one I was saying, I am not going into this cos inverse A, B, C, etc. So it pertains to a specific triangle, and given this triangle, just an example, how small a, small b, small c, and capital A, capital B, capital C are defined, that has been shown. I am not going to describe once again. So given a typical triangle as it is visible in the right hand side figure, excuse me, as it is visible in the right hand side figure, such a triangle, from such a triangle, typical triangle, we may obtain small a, small b, small c, and similarly big A, capital A, capital B, capital C. Now, how many triangles are there? Few moments back I was discussing. So since 23 such landmark points are identified or taken into consideration, so 23C3, which is 1771 mini triangles, are formulated over the face using 23 landmark points. Okay. Now, for each and every out of these 1771 mini triangles, it has unique identification like this in terms of small a, small b, small c, and capital A, capital B, capital C. So they are indexed in this way. This lower part of the slide is showing. So this particular vector, I should say, with 6 different entries, where 3 sides and 3 angles of the triangle are appearing, and here I, J, K in the lth frame of the mth sequence. Okay, so there are so many indices indices applicable here. Now, first of all, there are multiple frames we are working on, so frame has to be indexed. There are so many sequences working, so different sequences have to be indexed. Different triangles have to be indexed. Different sides of, different sides of the triangle and different angles of the triangle have to be indexed. So many factors are there. So in order to indexing them properly, there are few indices we have used. where I, J, K, M, L, these are indices, and small a, small b, small c, capital A, capital B, capital C, these are basically available quantities as available from a typical image or a typical triangle from an image. Okay. Now this, how they are calculated is this school level geometry. So just for quick recapitulation, they are this small a, small b, small c, and capital A, capital B, capital C, they are evaluated in this way. So please see that it is very basic geometric evaluations that we have made for our purpose. Nothing very, very advanced type of things or notionally very difficult things. No, nothing. Now, fuzzy triangle based geometric feature exploration. Okay. Now here is the catch. So when it comes to the question of fuzzy characterization, we must be aware that there must be an universe of discourse. The universe of discourse is defined like this, which is represented by U, which is basically characterized as a triplet or collection of triplets, capital A, capital B, capital C, where capital A, capital B, capital C are specified like this. The first among the triplet, that means A, is the biggest angle of the triangle. B is the next larger value, and C is the smallest of the three angles. And the angles may be non-negative. It's understood. Okay. So, and this is the triangle specification. That the sum of the three triangles must be 180 degree. So any angle specification with this requirement fulfilled will come or will be included in the universe of discourse. And definitely any such triplet, angle triplet, will give rise to a triangle. If we look at it from the reverse side, there is a face image, there is a triangle, obtained by joining three landmark points. So definitely that particular triangle formed like this will be an element of the universe of discourse. Understood. But next comes the evaluation of the membership. That means out of different categories of triangles, given a particular triangle that we find, what is the membership with a specific type of or specific grade of triangle? That is represented in terms of these membership values mu. Okay. Now, because of shortage of time, I cannot explain further, but these memberships are calculated very, very cleverly, and they are done in such a way that this is basically the contribution in such a way that the nature, given a nature of a particular triangle or a specific triangle, it will be characterized with some tolerance or approximation out of these categories properly. So accordingly, they are indexed. Mu I is, this is the right hand side, lower part. Mu I is the fuzzy isosceles triangle membership. Mu R, fuzzy right triangle. Mu IR is the right isosceles triangle. Mu E is the fuzzy this should be equilateral, fuzzy equilateral triangle. And mu T is any other type of triangle that we can perceive of other than the previous, this already described. Okay. So just to give you some idea, here it is. Different triangles or triangular shapes on face images, how they may look like. So different categories. The leftmost one is fuzzy isosceles one. The second one from the left is fuzzy right triangle. Third one is fuzzy right isosceles one. Fourth one from the left is fuzzy equilateral triangle. And the last one is, I mean, belonging to not exactly within these four categories, but generally it is a triangle, definitely. Okay, now fuzzy triangle based, to continue, 5 different fuzzy triangle membership signatures are formalized to signify a particular face video sequence in different ways. Accordingly, they are given adequate terminology, FIS, FRS, FIRS, etc., depending upon way of their representation. Okay? So I am not exactly going into further details. This is just the mathematical formalization which is being indicated here. Now sequences of n frames were n equal to 10. So basically here any transition that we have considered from neutrality to peak contains 10 frames, with 8 being the intermediate and the neutral one and the peak one. So 8 plus 2, that means 10. So how many triangles, the number of triangles that came under the consideration was 1771 we have seen. So how many frames we have to deal with? For each there is 1771 and there's 10 such for any transition. So when it comes to the question of a transition, then we have to deal with 1771 zero many triangles. All right. Now basically the MLP classifier we have used, where we have used at the output layer 6 nodes. Why 6? Because ultimately 6 categories or 6 type of transitions we have to identify. Neutral neutral to anger, neutral to surprise, neutral to happiness, neutral to fear, so on and so forth. So there are 6. That means neutral to one of the basic out of the 6. Input is definitely 1771 zero many. There is a hidden layer with 10, and then the hidden layer nodes or the intermediate layer nodes and the output layer nodes, they have to they have to parameterize with their respective biases. Biases are tuned very taking into account different possibilities. Once again, I'm not exactly going into the details of this. MLP classifier otherwise is a very old one. Only thing we have tuned it according to our requirement in the present context. So classification is done with one input layer containing 17710 many input neurons, hidden layer with 10 hidden neurons, and output with 6 neurons being used. This perceptron as a classifier is subjected to learning with scaled conjugate gradient backpropagation learning algorithm. So the learning algorithm that we have adapted in the present context is SCD. Now the question may come, why SCD? There are various learning algorithms as well. In fact, we have explored. SCD has been found to have given very impressive result. So whether in terms of time, in terms of convergence rate, in terms of accuracy achieved, everything together. So it's a good option. That is why SCD has been picked up. Input dataset is divided in non-overlapped manner in 70:15:15 ratio, where 70% means for training 15% for validation, and 15% for testing. So this is the algorithmic description. In fact, we have tried to explain it. It's just written in an algorithmic manner, nothing more than that. So our data sets used extended concordance CK plus M&M initiative, MMI dataset, mark dataset, multimedia understanding group, in short. So these are the benchmark datasets used for testing and validation of our effectiveness of our method, basically. So the results are evaluated through the computation of confusion matrix. Typically, confusion matrix is used to judge or to get how fairly a particular method has done. Okay, so typically confusion matrix is one such metric we have used here, and other measurement matrices such as false acceptance rate, what is known as FAR. Definition is given, FRR, and error rate. These are well-known metrics, and we have further adapted k-fold cross-validation for the effectiveness of all proposed signatures. Here, for our purpose, we have used k equal to 10, that means 10-fold cross-validation. Am I audible?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Thank you. So, when it comes to the question of different data sets, coming to CK plus data set, there are different data items available. Anger, contempt is somewhat mixed, but it is available in CK plus data set. So anger, disgust, fear, happiness, sadness, and surprise. So total 327 many such instances are there. Now, when it comes to the question of, specification of the triangle or triangular signature and fuzzy signature, the way we have done, we have obtained overall accuracy of 97.55%. For FRS, the overall accuracy achieved is 98.176%, just above 98%, and for FIRS, it is 98.47%. This is in respect of CK plus dataset. Now, let me admit one thing quite frankly, that CK plus dataset is easy to handle. It doesn't require any pre-processing. When it comes to the question of MMI datasets, or there are other datasets as well, which are difficult, because in MMI datasets, there may be faces with specs, faces with beards, faces with turbans. That means external factors are there which are not exactly contributing to the face images insofar as recognition of emotion is concerned or expression recognition is concerned, but somehow they are there. So all these together, all these extraneous factors like turban, presence of beard, specs, etc., they create problem. So that is why typically achievement in MMI dataset is a challenging one. Okay, so coming to fuzzy equilateral FES, it is 97.85%, and other categories 97.24%. After all this, how to sum up? All signatures are able to find out the common pattern of changing behavior over the transitions of happiness and surprise emotions. The fear transition is found more difficult to detect perfectly. Somehow, in CK plus dataset, transition into fear from neutrality seems to be a bit more difficult compared to others. Fuzzy right triangle signature and fuzzy isosceles and right triangle signature, that means FRS and FIRS, are showing higher performance or performance supremacy compared to other four signatures by achieving more than 98% overall accuracy. So this is the finding with respect to CK plus dataset. When it comes to the question of confusion matrix, this is the matrix. The diagonal entries indicate proper classification and off-diagonal entries indicate misclassification. So for example, the left-hand side topmost one, so anger being classified as anger in 43 occasions, but anger being classified as disgust in 2 occasions, which means that, well, some confusion has taken place so far as the performance of the classifier is concerned. So the confusion matrix for different type of signatures are presented here. Coming to different type of other performance metric, FAR, FRR, and ERR, which we have already indicated. So these are the corresponding graphical representation that we have. Coming to the next one, this is the MMI. Just look at the overall accuracy, as I was indicating. The level is something around 92%, 93%, something like that. Drastically below compared to that obtained in the case of CK+. MMI dataset is found pretty challenging to recognize all basic emotions. FIS and FES showing impressive performance out of all, but that is also to the level of 93.56% only. So this is a good point where one can think how to come out of this or make better showing, getting a hold of even better classifier. Confusion matrix corresponding to MMI was shown here. Misclassification is definitely higher. The results overall accuracy also has reflected like this, like that. Coming to FAR, FRR, and ERR reporting of corresponding to MMI. So these are here. Okay. I hope I am audible. Okay. Am I audible?
Yes, sir. Yes, sir.
Okay. So next comes MUG, MUG, where the overall accuracy is pretty encouraging, 98.87%, 100%, 99% even. So maximum shape variation information is collected from the transition of fear in emotion. These are the salient, findings. Transition of happiness is found more difficult compared to other emotions. FRS and FIRS ensure more impressive performance with overall accuracy above 99% in case of MUG. Corresponding confusion matrix and corresponding other performance parameters, FAR, FRR, ERR, etc. Now, as I have indicated, we have adapted k-fold cross-validation, 10-fold cross-validation. We made comparison among different data sets available, or rather we have worked on CK plus MMI and MUG in terms of accuracy. So the 10-fold cross-validation results are reported above, while the overall accuracy is being reported at the bottom. So needless to say that MMI indicates more challenging one, may it be in terms of 10-fold cross-validation or overall accuracy. CK plus is a bit easier, and the easiest one is definitely MUG. So this is the common comparative results indicate. That is what is coming out of the comparison. This is the extensive comparative synopsis, whatever we have done in this context. That is, this is the synopsis view. So complexity wise, other things we have already explained. Complexity wise, with 68 original landmark points, had it been the original landmark points, the complexity or the number of cases that we were supposed to handle was 50116, 68C3. We have downsized that by identifying 23 most sensitive out of this 68 and bringing down the complexity to this level. This is for a single triangle. And when it comes to the question of the entire system, so it has to be scaled up, both the sides. So computationally, we are achieving this much. This is just a computational comparison. Do I have time? Perhaps not.
Sir, next session is from 11:45.
But there are thoughts. I think let me stop because
yes, sir. As per
if
your
we start,
convenience,
then there may be it may not be possible to sum up within the stipulated time.
Okay, sir. No problem.
Okay, I will be happy to face questions.
Yeah. Thank you, sir, for your descriptive and illuminating talk, and with a very relevant application which can be extended, or I think it is already been done with the researchers in relevant field. Sir, as just before I go to the participants for question, from a point of interest, I just want to know, like as you were saying that the data sets with some external things like specs or beard, which is not actually contributing to perfect face recognition. Sir, is there any data set with faces with masks? Because nowadays mask is indispensable. We are everywhere with
Very
masks.
good question. Very good question. Yeah, because nowadays it is really something which must be given due attention to.
Yes, sir.
To the best of my knowledge, I have not found. But thank you for raising this point. In fact, we have to see that whether there is any further data set, benchmark data set available with faces, masked faces like that.
Yes, sir.
But
Because
to be honest, no,
yes,
I have
sir.
not explored.
Yes, sir. Because wearing masks, a face.
Because see that
yes,
it becomes even more challenging. Let me just put one or 2 points. Because the moment you deal with a masked face, you lose nose, major part of nose, you lose lips. Naturally, the question of the landmark points over those regions, you cannot get any idea, right? that means you have to truncate your landmark dataset drastically. And not only truncate, the most sensitive parts or sensitive regions are truncated. So I am not very sure just hidden Markov model, this is basically hidden Markov model deals with hidden data or data not fully available, may come to some help, but I am not sure. This is just a hunch that I am and my somewhat experience on the basis of which I can I can say. But how much it is going to work, I don't know. But it's a very good point and very relevant, direction that one can think of. But another point is another bottleneck may be the benchmark data being available. That we have to explore. No, not that I know of at least so far.
Yes, sir. In that direction, I think the research will proceed with the
It's a
natural.
very challenging one. I'm
Yes, sir.
telling you,
Yes, sir.
very challenging.
Yes, sir. So, thank you very much, sir. Actually, with these emerging areas or topics that our respected speakers have already exposed us for last 4 days, and this is the fifth day, that is helping us to think towards the direction they are already giving to us. So I think participants are also in with the same line of thinking. So with that, the session is open for all. You can post your question or you can raise your hand so that you can be unmuted and you can directly interact with our respected speaker. So there is one question, I think. Yeah, I am reading it out. Can you please explain again on the triangle membership functions for the image analysis? Question is from Shantoni Shaha.
Okay. Um, am I audible?
Yes, sir.
Yes, sir.
Yeah. The idea is that uh, in reality, in real life, um, I mean, it's not possible always to classify triangles in in specific way. For example, the example that I provided, if it is asked a triangle with angular specification 59 degrees, 60 degree, and 61 degree, is it an equilateral triangle? From classical mathematical point of view, answer is no. Big no, no. But when it comes to the question of interpretation, real life interpretation, and making your finding and analysis upon that, uh, what we think, definitely classically it may not be an equilateral triangle accepted, but it is very much close, very close to being an equilateral triangle. Now this very close, that means very close approximation, that is what is being captured. Let me give you another example that in real life that happens. In fact, that happens more. For example, two persons are standing wide apart, say 10 feet from one another, and you are the observer. This is the example that I usually provide in my class. Okay, but this is very much relevant here also. That is why, please allow me to provide this example. So 10 feet away, apart, two persons are standing. The height of one is 5 feet 10 inches. The height of another is 5 feet 11 inches. Okay, and you are standing as an observer, maybe 20 feet from them. Now we were asked, these two persons, are they of same height or not? Answer in Boolean, either yes or no. It's extremely difficult. It's extremely difficult. No. So there exactly lies the power of, I should say, I deliberately use the term power of approximation, power of tolerance. The moment I confine my understanding that 60 degrees, 60 degrees, 60 degree is what, in classical sense of the term, is what an equilateral triangle may be defined, I lose many. But if I am a bit flexible, I allow, no, 59 degrees, 60 degrees, 61 degrees, somewhat very close, may not be exact, but somewhat very close to equilateral triangle. I get many more in my family. So I can tolerate up to 1 degree, say for example. Okay, 1 degree deviation I can tolerate. I can get many more. If I am able to, or if I am allowed to accommodate 2 degree deviation, I get even more. But well then, there is a level of compromise that you can think of, or that you have to decide. To what extent you can tolerate? Up to 1 degree relaxation, up to 2 degree relaxation, or what? That is a separate issue altogether. But given some tolerance, the moment you allow tolerance, then you are able to address many more under your fold, and by virtue of this, you become powerful. Suppose, very simple, you are given one triangle. Can you learn your, say, multi-layer perceptron with a single instance? Answer is no. But if you become flexible, say 1 degree flexibility or 2 degree flexibility or whatever, and you learn accordingly. Now the question is, can you train your MLP? Answer is yes, because there are so many included in the family. Family has grown, may not be in exact sense, but somehow to reasonable degree of approximation. Now, so far as this present problem is concerned, what we are trying to do, any triangle belongs to any 4 categories, not 4 plus there is other categories. So out of these 5. Now I have given you, the membership definition is given. Now given a particular triangle, I give you a triangle, so for example, and ask you which type of category it is most befitting. So what do? Given that particular triangle, you find out or evaluate their respective membership functions with respect to different classes, different fuzzy membership classes out of this 5. And you see that the maximum membership is, say for example, in isosceles category. Then what should be your conclusion? The triangle that you have provided to test gives me impression that it is among these 5 categories with their respective relaxations offered, the best fit is isosceles category. That is, it is a fuzzy isosceles triangle given that particular level of approximation that I am allowed. Is it clear now? Is it clear?
Shantani madam? Prem Kumar, can you please unmute Shantani?
Yes, ma'am. Yes, ma'am. Shantani ma'am, please unmute yourself. Shantani ma'am, are you there? Yes, ma'am. Shantani ma'am?
Hello?
Yes, ma'am.
Yes, yes, it is quite clear. Thank you for the explanation.
Okay. Thank you. Any other?
So any participant, please raise your hand. You can interact or ask anything related to this session with sir.
Okay. I think
Sir, okay,
there
sir.
is.
Could you please share we can share your email ID with the participants.
Sure,
If
sure.
they
Most
have,
welcome.
yeah, if they have anything to know,
Most welcome. Anybody. It's just openly announced
yes,
that
sir.
in case you need any, you know, uh, some technical clarification or whatever, feel free to drop a mail, my email ID. I'll be happy to come in contact with you. I mean, in online manner, of course.
Sir, shall I write your email ID in the chat box?
Sure.
Gmail ID, sir, yours?
In fact, yeah, very simple. My name,
Yeah, yeah,
paramartho.dotto at
yeah.
gmail.com.
So I'm just
All
writing in the
small.
chat box. Yeah.
Yeah, is right.
So it is there in the chat box. You can have a note, and in future, if you need to have any help regarding research, then you can communicate with sir. So we are at
So
the end
thank
of,
you very
yes
much.
sir, yes
Thank
sir,
you very much, my dear colleagues. Thank you all.
yes
So
sir. So we are at the end of session 1, day 5. And thank you very much, sir, for being with us and for this wonderful session, is already illuminating our minds with new thoughts in the direction that you have shown through your presentation and explanations. So, on behalf of the organizing committee of Department of
my
Computer Science
pleasure.
and
My
Engineering,
pleasure.
yes, sir,
My
of
pleasure.
Maulana Abul Kalam Azad, University of Technology, West Bengal. I express my heartfelt thanks to Sir for your wonderful session. So in future, we would be happy to invite you again in future events as well. So for now,
Thank you.
thank you so much, Sir. And we will close the
Okay.
session rather we do not have any time to close the session because from 11:45 there will be next session. So
Please allow me to leave. Okay.
yes, sir. Yes, sir. Yes, sir.
Thank you. Thank you.
Thank you, sir.